It's a privilege for me to be able to open this conference and chair this session. And I guess I should start out by pointing out the ground rules. Since we have a long day ahead of us, I will try to do my best to make sure that our dear presenters here stick to the time slot that they've been given. So I'll give you a warning when you're about 5 minutes down, and then when you're sort of one minute away from your sort of the time I'll cut you off, you'll be given a red card, and if you then continue, I'll find a way of stopping you. My expertise is coercive diplomacy and use of force, so, and my motto is violence works. So usually I succeed in doing that, but I hope it won't come to that. Instead of starting now by reading out aloud from the bios that you've all been given, I'll simply just give you a quick idea about what we're going to hear. First, we're going to get 2 scenarios from Leif Toudal, who will sort of start off by looking at what we can expect in terms of how much ice will be melting and so on and so forth. Then we'll move on to the more political aspects of this. And Scott G. Borgerson here on my left will look about whether we are going to see a new great game in the north. And then finally Sven G. Holzmark will be looking at whether we can expect cooperation and confrontation. So without further ado, I will hand it over to Leif and let him start off with telling us how much we can expect in terms of melting ice and so on and so forth.
And good morning, everyone. And it's a pleasure to be here and be able to tell you about climate predictions for the Arctic. The title of the talk is The Cold Facts, 2 Scenarios for Climate Change in the Arctic. Actually, the way I've sort of organized the talk, I'll first talk about the climate changes that we've already seen in the Arctic, and then I'll address the issue of what we can expect in the future. Let's see. First, some words about the climate change that we've already seen in the Arctic, sort of summarizing the facts. The average ice extent in the period 1979 to 2000 in the summer minimum in the Arctic was 6.7 million square kilometers. In 2007, we saw the hitherto minimum ice extent of 4.13 million square kilometers. And the last couple of years, we've seen a slight increase to 4.5 in 2008 and 5.1 in 2009. The bottom line here is that the last 3 years have had a substantially lower ice extent in the Arctic than the previous normal ice conditions. And these curves show the temporal evolution over the summer periods of the last years. The black thick line at the top is the normal evolution of ice cover during the summer period from June to October in the period 2000 or 1979 to 2000. The gray area around it is the standard deviation, and then the individual lines that you see at the bottom are the development of the ice cover in 2005, 2007, 2008, and 2009. So 4 out of the last 5 years in the Arctic, we've seen very much below average ice extent. So this is one of the facts that we've already observed in terms of climate change in the Arctic. So what does this mean? Well, this means, for example, that the Northwest Passage, the sea route north of Canada, to some extent have been open. Whether these sea routes are open or not is sort of a matter of definition. But as you can see on the figures at the bottom of this slide, in 2008 and 2009, there's a substantial amount of open water in the passageways through the Canadian archipelago. You see Alaska on the left side and the Canadian archipelago on the right side of these figures, and they illustrate that we have a substantial opening in the Canadian archipelago and a potential shipping route that is opening up. Similarly with the Northern Sea Route, the route north of Russia, also here in the latter 2 years at least, we've seen an open Northern Sea Route with the possibility of shipping through or north of the Siberian mainland. In 2007 though, which was, if you recall, the minimum total ice extent in the Arctic, the Northern Sea Route was still blocked near the Severnaya Zemlya and the Vilkitsky Strait. So even though that was the total minimum ice extent year, this sea route was not open. Why do we see climate change in the Arctic, and why is climate change sort of enhanced in the Arctic? Well, the ice albedo feedback that you might have heard about before is one of the main players here. Open water reflects only about 7% of the incoming solar radiation. So when the ocean is open, most of the solar radiation that reaches the ocean surface during the summer is absorbed in the ocean and heats the ocean. Whereas a snow-covered sea ice reflects about 85% of the incoming solar radiation. So much of the solar radiation that hits sea ice is reflected back into the universe and does not heat the surface of the Earth. Bare ice has a slightly lower reflection than snow-covered ice, but still a substantially larger reflection than open water. So as the ice cover decays, this highly reflecting snow and ice surface disappears and is replaced by open ocean. This means that we will have more solar radiation absorbed by the ocean, more heat of the ocean, and then thus more melting. So this is the positive feedback mechanism that enhances melting, so more melting will cause even more melting. This was what's happening to the ice extent, and the last slide also has some bearing on the thickness of the ice, because another set of observations that has been or has sort of surfaced during the last 10 years is observations of ice thickness. Ice thickness until recently was not observable from satellites. So the data we have on ice thickness are from submarine cruises during the Cold War. There was a substantial amount of submarine activity under the ice in the Arctic. And from measurements over a large area of the Arctic, the average thickness in the period 1958 to 1976 within this area was about 3 meters. After the Cold War, the US initiated a number of scientific submarine cruises to the same area, covering the same area at the same time of year. And during then the period 1993 to 1996, they found that the thickness of the ice had decreased to 1.62 meters. Again, submarine data. In 2003, NASA launched a satellite that is capable of measuring ice thickness, or actually what it measures is the freeboard of the ice, the part of the ice that sticks above the ocean surface, and from that you can infer ice thickness, relating that to the previous measurements from submarines with careful calibration. That data set from 2003 to 2007, again from the same area where the original submarine data was from, now has revealed that the ice thickness has decreased further to 1.43 meters. So a substantial decrease. Actually, the ice now is less than half as thick as it was 50 years ago. And why is that so? Or background material to that, these figures show in white the old ice in the Arctic. That's ice that has survived the summer period, and in gray the young ice. That's ice that's formed in the current winter. So all the pictures are from February, and they are from the year 2000 until 2009 at the bottom right corner. And you see that the white area in the beginning was rather large, and in the last years the white area is much smaller. So what we have seen as of changes in the Arctic is that the area that is sort of inhabited by this old thick ice is becoming smaller, and whereas during the winter the ice or the Arctic always freezes up with ice, but that means that then a much larger part of this ice is young ice formed in the current winter. This young and thin ice obviously then is more susceptible to melting in the following summer, and that's really what we've seen in the summers of 2007, 8, and 9, that this large area of fairly thin ice formed during the past winter also melts much more rapidly than what we saw in the past, where a larger fraction of the ice was thick and old.